Hello, Hitesh.
Hello.
Yeah.
Hello.
Yeah, I can hear you.
Okay.
Just so last class, let's just see what we can do today. So we are done with these things. And these questions are very, very simple. I don't think we need to practice it here. Let's just move on to the next chapter. That is how light behaves. Reflection is the bouncing. Okay, reflection we have to reflection of color. Reflection of curved mirrors. And then refraction. Refracted is okay. So today we'll talk about reflection and refraction.
Okay.
Any idea about reflection and diffraction? You must have studied in your earlier classes.
Well, reflection, refraction.
What have you studied?
About this.
Yeah, reflection might be you have
Yeah.
learned about
In primary school we did reflection, refraction.
reflection and refraction also.
Yeah, both of them. Uh, reflection is like when the light reflects off of a medium,
Okay.
and refraction is when light like shifts its path when it's like traveling through a medium, causing it to like bend.
Yes, bending of light, right? When it goes from one
Yeah.
medium to another medium, that is called refraction. Okay, so one by one, we will try to understand reflection and diffraction. So they are just see that ray model of light. First, I will give you this thing. What do we mean by ray? Ray model of light. Simple, you'll just understand this thing. What do we mean by ray model of light? This model assumes that every luminous body, first of all, let us just divide the bodies. Like in this universe, whatever kind of bodies are there, we can divide them into two categories: luminous bodies and non-luminous bodies. All bodies, like first, let us just try to understand these things. All bodies can be divided into two categories. First thing, luminous bodies. I think you know these things. Luminous and non-luminous. Luminous bodies. So luminous bodies means what? Luminous bodies, they can produce their own light. Their own light. For example, the sun star, firefly, candle, all of these things, they can produce their own light. So they are luminous bodies, right? But is moon a luminous body? Non-luminous bodies, they cannot produce their own light. They cannot produce their own light. For example, there are so many things that stone, wood, anything, even the moon, earth, they are non-luminous bodies. So why does moon appear to be yellow? If it does not produce its own light, then why does it appear to be lighted? At night, when you look at the sky, you see a yellow colored moon. Why? How does it? I told you that it is a non-luminous body, so it cannot produce its own light. Any idea? Do you think that the moon is yellow because it is producing yellow light? Or what could be the reason behind its yellow color? Can you hear me right with this?
Yeah, now I can hear you.
Or did you hear my question? What I asked?
No, I didn't know you asked the question. I don't think I heard you.
Oh, I asked, tell me how moon appears to be yellow, right? We are talking about luminous and non-luminous bodies. So luminous
Yeah, yeah.
bodies can produce their own light. Non-luminous bodies cannot produce their own light. So the sun,
It's it appears yellow because like the sun's like rays
it reflects
reflects
the
onto the
right.
moon.
It appears yellow because it reflects the sun's light, right? It reflects because sunlight has 7 colors. We have seen this thing, Vibgyor. So it absorbs all the colors of the light, but reflects the yellow color. That's it. The moon appears yellow because it reflects. The moon appears luminous because it reflects the sun rays, or by reflecting the sun rays. What is it? Reflecting the sun rays. Simple, right? So we will try to understand these things. So all the bodies are luminous and non-luminous bodies. Just see that. But when the light is falling on a particular body, that let's say that it is a non-luminous body. This is a stone, a piece of a stone, and light is falling from it from all the directions. So what happens? That light, a part of that light will be absorbed by it. Let us say the light is falling into it in all the directions. First of all, let me just define this thing. What do we mean by ray? Ray means light always travels in a straight line. Light always travel in a straight path. That straight path is called ray. For example, if there is a source of light, it will send out the ray in various directions. So I will say that the light is traveling like this. Light always travels in a straight line. So this is the source of light, and it is sending out rays in all the directions. So these are the rays, or the rays may be coming towards a particular body or particular thing. Then we say that here they are converging, right? Here they are converging. Light rays are converging at a particular point. So these are the things. So ray is very simple. You just remember light travels always in a straight line, and that straight line itself is called a ray. So ray is always straight. Ray can never be bent. Although we saw the bent ray, that is, we will make some diagrams where the rays will be bent, but ray is always straight, right? Just see this thing. That will mean something, and that will be explained in the image itself. So just remember this. This is the ray, and this is how we represent the light. How light is, because we cannot see the light. In the presence of light, we are able to see the object. Suppose there is an object like this, and the light is falling on it like this in all the direction. It will absorb a part of the light, and then it will do what? It will reflect the light in various directions. Like a sun, every tiny object will act like a sun, but only difference is that they are not producing their own light. They are rather just reflecting the light which they are receiving from the other sources of light. And because of these things, some of these reflected rays reaches out to our eyes, and that is how we are able to see things around us. So if there are no sources of light, there will be no reflections of light, and no light will be reaching out to our eyes from the object, and we will not be able to see the things. Simple. Is that clear? You're getting what I said, Hitesh?
Yeah.
Okay. So let me just see the book. What do we have to do? So reflection is the bouncing of light off a solid material. Simple. So how do we define reflection? Bouncing of light off a solid material is called reflection. Let me see some pictures. I need to upload this thing, rules of reflection. These laws of reflections are not given in your book, but they are very roughly mentioned in your book. Let's just do it in detail a little bit so that you can understand these things. See, these are the laws of reflection. This thing you have to remember, and you will be learning about these things in higher grades also in different ways, but I want you to know these things right now because we have to understand now these things. Laws of reflection tells you, simply just see that these are the laws. The angle of incidence I is equal to the angle of reflection. The incident ray, the reflected ray, and the normal all lie in the same plane. Let us try to understand these things. What do we mean by this thing, right? Plane mirror. Plane mirror is just let us just say that reflection is the bouncing of light off a solid material. And what do we mean by mirror? Mirror simply means any reflecting surface. Doesn't need to be the looking mirror all the time or the side mirror in the vehicles. Mirror means any reflecting surface. Any reflecting surface. Like if there is a silver coated screen, that is also a mirror, right? Because that reflects the light off its surface. So that is why that is also a mirror. So any reflecting surface is just called a mirror. A plane mirror, there are two kinds of mirrors that we have to study. The plane mirror and spherical mirror. Spherical mirrors, two types of mirrors, concave and
And
convex.
opaque. Oh, never mind.
No,
Okay,
opaque.
concave and convex, right?
Opaque is different thing. The transparent, opaque, they are different thing, right? The way light interacts with the matter, in that way, it has been defined in, it has been categorized into three categories. Like this, I said that all the bodies can be categorized into two categories: luminous bodies and non-luminous bodies. Similarly, all bodies can be categorized into three categories. Okay, by the way light interacts with them. Okay, let's write down that thing as well. The bodies can be categorized into three categories by the way light interacts with them. By the way light interacts with them. You said this thing, one thing is transparent. Second is opaque. And third is, do you know, third one? Transparent, opaque. There is one more. And it's that it starts
Translucent.
translucent, correct. So transparent, it allows the light to pass through it, right? Transparent materials interact with the light in the way that they do not obstruct their paths. They just allow them to pass through it. Transparent materials allow the light to pass through them. Opaque materials do not allow the light. Light to pass through them. These are very obvious things, but still, let's just discuss this. But the science is very deep. In high grades, you will learn about more about these things in greater detail, but you need some more advanced concepts to understand these things. Translucent material partially allow the light to pass through it. Allow light to pass through it. That's right. So this is how, just see that there are two categories, luminous, non-luminous. They are categorized by the different way. The
Yeah, okay.
criteria, because that means what? Whether a body can produce the light on its own, or they depend on other bodies to produce the light. Whether they can produce their own light. So on that way, now on that basis, they have been categorized into luminous and non-luminous bodies. But in this way here, we are just talking about when the light falls on a particular body. How does it react to that light? How does it interact with that light? If it allows the light to pass through it, it's transparent. If it doesn't, it is opaque. If it partially allows it, then it is translucent. Simple, right? So the basis for categorization is different for both the cases. Okay, let us now try to understand the laws of reflection here. Done? You're done writing?
Nearly.
Okay, let me know when you're done.
Yeah, I'm done.
Okay. So now let us try to understand this thing, how reflection takes place. So ray model of light, we were talking about ray model of light. It means light, how can we see the light? Ray model of light says that we can see the light in the form of rays, because lights always take the light always travels in a straight line. Although light is invisible, but we can graphically represent the light in the form of rays. That is what we meant by ray model of light. This assumes that light is simply a ray. This model assumes that light is a ray. What is a light? Light is an electromagnetic wave. Light is a stream of photons. You can say these things, but the ray model of light, it doesn't bother about these things. It can be electromagnetic wave. It can be a stream of photons, but it only tells you about how it propagates in the universe. So that is what ray model of light says. So light can be studied in the form of rays. So that is what ray model of light. And ray is simply what is this? If this is a source of light, then the light will be going in a particular direction, something like this, and this will go infinitely, something like this. This is OA. Just like in mathematics, how do you represent a ray? This is the thing, right? Ray is represented like this, OA. So it is bound at one side and infinite on the other side. But you don't need to bother about those things at this point of time. You just need to understand this, the basic principles of reflections and refraction. So let's just try to understand this plane mirror. First, we will study the reflection with the help of plane mirror. Let us say that this is the mirror. Plane mirror, just see that it is a plane surface, evenly spaced plane. Although it is shown like this, but the plane mirror is like a 3D, 2D picture. It is a surface like this. And when the light falls on it, and then it reflects in a particular direction, something like this, it goes into this way, and then it reflects into this direction. So this is the point where it lands. So just see that this ray will be called incident ray. This ray will be called reflected ray. And just see that to any surface, we represent a normal. Just draw a perpendicular to the surface. This is perpendicular to the surface, and this line is known as normal. And this thing, angle between the incident ray and the normal is called angle of incidence. And the angle between normal and the reflected ray is called angle of reflection. So angle I is the angle of incidence. Angle R is the angle of reflection.
Yeah, I'm done copying it down.
Okay. So now let us come back to the laws here.
Wait, so could you go down to that again? You
This one,
take plane mirror? Yeah, yeah, okay.
done.
Yeah.
So just take a look at this thing. Now laws of reflection, when you try to understand the laws of reflection, then this will help you a lot. First, actually, this order is given in the wrong order. First, let me just get some more picture. Better ones, better ones. Yeah, this one is better. Look at this thing. This is called laws of reflection of light. The incident ray, reflected ray, and the normal to the mirror at the point of incidence. Okay, I didn't say like the point at which the light falls. This thing is called point of incidence. Point of incidence. Incident ray, reflected ray, and the point of incidence and normal. About normal, just see that if the mirror is placed like mirror is normally usually represented by the straight line. If the mirror is placed like this, the normal will always be perpendicular to it. Right? This is the normal. Normal is always perpendicular to the mirror. No matter which direction the mirror is placed. Suppose the mirror is placed like this. If the mirror is placed like this, then the normal would be like this. It is always perpendicular to the mirror. If the mirror is something like this, if the reflecting surface is this, if the light falls on it like this, in this direction, first of all, you need to draw the normal. And normal is always perpendicular to the surface. This is normal. That is what happens. So normal is this. So normal is always perpendicular to the mirror. Always remember. So now that you understand what we mean by incident ray, the reflected ray, the normal to the mirror at the point of incidence, the point of incidence, all lie in the same plane. What it means, very simple, just see this thing. They all lie in the same plane. Look at this thing. If the plane is like this, if incident ray lies on this plane, and this is the normal will also lie on the same plane. The reflected ray can be out of the plane also, like it is outside this thing, right? Something like this, outside like this. It could be like that, or it could be anything like into the screen and out of the screen, something like that. But it says that if the incident ray is like this, then the reflected ray will also be on the same screen. It will never be out of the screen or into the screen. It says that incident ray, normal, and the reflected ray always lies in the same plane, right? So they can never be. Like if this is a reflecting surface and if there is a plane, if light is falling on one plane, then incident ray, reflected ray, and the normal, they will all lie on the same plane. That is it. Is that clear? The first law? You can write down this thing, laws of reflection.
Okay. Wait 1 second, sir.
Okay.
So should I write this down?
Yeah, yeah. Write down the laws of reflection. This is important.
Okay. Yeah, I'm done.
Okay. So the first law, is that clear? The first law? Incident ray, reflected ray, and the normal, they all lie on the same plane. You see, you cannot feel this law. Let us say that the mirror is something like this, a plane surface. And just imagine that there is a plane like this on this surface itself. Now it is saying that this is the point on this on the mirror. This is the mirror. This thing is the mirror. It says that if a ray, something, if a ray falls on this plane, then just see that it is quite possible. Just in first law is simply say that angle of incidence. This is they all lie in the same plane. First we'll have to draw the normal here. Normal you will draw on the same plane. This is the normal. And reflected ray will also be on the same plane. That is how we say these things. Like this is incident ray, this is reflected ray, and this is the normal to it. Normal is always perpendicular, but just see that this, and the second law tells us that angle of incidence is equal to angle of reflection. This is angle of incidence and this is angle of reflection. It says that if angle of incidence is equal to 30 degree, angle of reflection will also be 30 degree. But that 30 degree can be, angle of reflection can be 30 degree in infinite number of ways. It can be out of the screen also, and this is also 30 degree. It is quite possible. But it says that this laws of reflection puts some restriction on this kind of possibilities, that no, everything is not possible. If a ray is falling, if it lies on a particular plane, then the reflected ray will also lie in exactly the same plane. It will never be out of the plane. That is the first law, right? Very important, this one. So it can be outside. Just see that. Just imagine that this is a plane, right? This is a plane. So ray can be on this plane and it can be reflect along the same plane also. But what quite possibility, angle of incidence is like this, can be out of the plane also. And in that case also the angle of reflection can be 30 degree. But it says that no, it will be angle of incidence will be equal to angle I is equal to angle R always. This will always be true. But this will, apart from having this equality, they will also lie on the same plane. It means this, and this will all lie on the same plane. All lie on the same plane. That's it. That is the first law of reflection, and this is the second law of reflection. Is that clear? This thing?
Yeah.
Okay. Now, in physics, whenever you come across this word or law, it means that's the universally accepted thing, right? No matter which part of the universe you are in, that law will be valid. Simple, right? So there are two types of reflection you can see: regular reflection and irregular reflection. Regular reflection says that parallel rays are falling on the mirror, and after reflection, they are also parallel in this case. So parallel incident rays and reflected rays are also parallel. So such kind of reflections are called regular reflections. And if the, let us say that if the rays are falling on the surface in any order, or even if the parallel rays are falling on it, after reflection, they can be in any direction. Right? They can be in any direction. So such kind of things are called irregular reflection. Okay, tell me this thing. Laws of reflections are valid here. You can clearly say this thing, right? incident ray, normal ray, and you draw the normal to it, and you can clearly see this thing, that angle of I is equal to angle of R, almost equal, right? Every point, no matter where you apply the laws of reflection, they will always be true. Like angle of incidence is equal to angle of reflection, any point, at any point. So laws of reflections are valid here. Is laws of reflection valid here also? Tell me, in this case, is it valid?
Yeah,
How?
because the parallel rays, it's a because it's an irregular reflection.
Irregular. How will you justify this thing? How the laws of reflections are valid over here? Just see.
Um,
Though here the surface was regular, right? In the first case, it was regular.
yeah.
When the surface is rough, something like this, and the ray falls on it, something like this, and then just see this thing. Just a small part of it is almost a plane mirror, right? Almost a plane mirror. It is something like this. So you will see that just draw a tangent to it. This is your plane mirror on which it is incident. And then draw the normal to it first. Then which direction it will reflect, you can predict which direction it is going to reflect. If I say that this is just 20 degree, so after reflection, it will also make an angle of 20 degree. So in this way, you can find out the direction of reflection. This will also be 20 degree. Similarly, if a ray falls here, suppose here, and at this point of time, this is your normal. Angle of incidence, angle of reflection will be like this. Okay. So just see this thing, it can be any direction. It can be in any direction. When the light falls here, you can see this thing. Here is this thing. So here, it will reflect along this direction. So in this way, you can predict which direction the things are going to be reflected on. Okay, I'm going to give you some exercises. Just do these things, right? Let us say that this is a plane surface. You can roughly draw it in your notebook. If the angle of incidence, if the ray falls like this, complete the ray diagram. Complete the ray diagram using laws of reflections. This is one thing. Second, I give you, let us say that this is this. The incident ray is like this. Complete the ray diagram using laws of reflection. Label the angle of incidence and reflection. Okay, this is one thing, and then there is complete the ray diagram. I have given you the incident rays in three cases. This is the C question. Complete the ray diagram.
Okay. So could you tell me how to do the first one?
Okay. It is exactly the same thing. Suppose it is given, right? Suppose I'm just giving you a random example. Let us say that
Okay.
this is the mirror. This is the plane mirror. And let us say that the incident ray is falling like this. Ray is falling like this. This is incident ray. Label it. Incident ray is coming from this side. So according to laws of reflection, what happens at this point of time? Angle of incidence must be equal to angle of reflection, right? In this
Yeah.
case, let us say that we draw the normal from this point that is perpendicular to the surface mirror. Just draw the perpendicular. That is the thing. This is your normal. You drew the normal now. And according to laws of reflection, just see that this is your angle of incidence, right? Angle of incidence.
Yeah.
You have to draw the angle of reflection, reflected ray in such a way that the reflected ray approximately has the same angle. I and R must be equal to the same. Just match it. Just see that if you want to rotate it as much as possible. Just it should have at least, like they should look at least equal. R and I should always look equal. And that is your reflected ray. That's it. This is what you have to do. Complete. This is, you can say this thing, this is angle of incidence. And this is angle of reflection. Show me the first one if you have done it. Do the first
But
one.
did I draw it in my book?
Okay, show me how you do it.
I'm still doing it, but
Okay, do it freshly on your notebook. You're confused. Any difficulty?
No. Yeah, I'm done.
Okay, show me. Okay, got it. So you have done
That second line over there was a mistake.
okay. So this is the incident ray, right? This is the incident
Yeah.
ray,
Yeah.
and this is you have to mark these things. You have to label them, right? This is the normal. So this is angle of incidence. Just show it I. Which one is the reflected ray? This one, right? This one.
Yeah.
Yeah. This is the angle of R. I, R. This is reflected ray. Angle of reflection. Fine. Just see this thing. Just call it incident ray. Incident ray. And this is reflected ray. So you just need to locate the reflected ray, which direction it will reflect after um, hitting the mirror. That is what you're trying to find out with the help of laws of reflection, right? Okay, tell me just by the way of looking these things, let us say this thing here. If the angle of incidence is equal to 0 degree, what will be the angle of reflection? Second one. Just see that normal,
0.
yeah, angle of reflection will also be 0. It
Yeah.
means it will reflect back along the same path, right? It went in the same direction, but it will reflect back along the same direction. If the light falls perpendicular to the surface, it will reflect back perpendicularly. Similarly, at this point, if I draw the normal like this, let us say that this is 30 degree. So reflected ray will be in which direction? This 30 degree, right? That's it. You can complete the ray diagram like this. Simple. Clear?
Yeah.
Okay. Let's do it.
So should I do the next one?
No, they are done, right? They are done. No.
Okay.
Okay, we'll stop here today.
Oh, okay.
Next class will I'll give you more questions for practice, right? So next
Okay.
week you'll have the session, right?
Yeah.
Okay. Okay then. Okay then. Bye bye.
Bye.